today we've been building to this point. Some of you have probably already decided this is how we're going to do things, but we're going to want to evaluate limits using our algebra skills and not so much, oh, here's a table of values we're going to guesstimate, or here's a graph and we're going to estimate. We allude to this process when we use the delta epsilon definition. Because if you recall, it says, in fact from Bellwork we did, we started with this problem. I didn't even give you this stuff. We had to actually plug a number in and say, oh, we think that's the limit. And by algebra, we plugged a number in that we're approaching to the function to see, did it give me an answer or not? So if we're talking about evaluating limits with algebra, first thing we want to try is just try the number x approaches and if a real answer is calculated, this is the limit. Or then this is the limit. Now, fortunately for you all, there have been a series of theoretical mathematicians that took the time to use the delta epsilon definition and prove for all kinds of various types of functions that if you just plug the number in and you get that value out, it actually is truly the limit. And so mathematicians have used the proof process to do that over all kinds of various functions. That's kind of nice of them, isn't it? So, that's part of what we do. So, just like if we have an example of something like this, if I ask you for the limit as x approaches 6 of 5x minus 30, can you give me that limit?
0.
Because?
Because 5 times 6 is 30, and 30 minus 30 is 0.
And so that means this limit would be 0. We can have 0 as a limit. That's okay. Because that curve gets to 0. Let's say you have the limit as x approaches negative 3 of 4x plus 10 over 6x minus 13. What's the first thing we want to do?
Plug in negative 3 for the x's.
So let's try to plug in that negative 3 for the x's. Let's see what happens. So we have 4 times negative 3 plus 10 over 6 times negative 3 minus 13. And what do we get? Anybody get 2 over 31? Got some thumbs going up? Like, yeah, that's what I got. That works. It's not undefined, it's a real number, right? So we have a value, an answer to this question. And as long as we get a real number from this, we just plug that number in and we keep going. But, this is math class. It never is going to stay that easy, is it? There always has to be some kind of exception to this rule. Try this one. The limit as x approaches 3 of, let's see, 4x minus 6 over x minus 3. We get an answer. That's undefined. We get a 0 in the denominator. And this has no limits. And that could be a conclusion to this process. But what we want to check before we actually say, you know what, I don't think that's going to be a limit, we have one more little bit of detail that we want to kind of work on. So we're going to think about saying, is there any kind of factoring that I could do to either the numerator or the denominator to maybe cancel out a common factor? So what do you think? Is there any common factor in the numerator? So if I factor a 2 out of the numerator, I get 2 times what's the remaining factor?
X minus 3, or 2 more x minus 3.
If I have any common factor in the denominator. X minus 3. So then now, could I cancel anything from the factoring process? Do I replace it and rewrite it as a 1? Sorry guys, no you don't. There's nothing that we can cancel. So then we're sort of done, and actually no limit is the result in this particular question. And that's okay, it can happen that way. We need to get past the fact that we always think we have to have a numbered answer. But also then there's other things that we can do. There's other problems that show up. So we can say things like the limit as x approaches 3 of, let's see, x squared minus 6x plus 9 over x squared minus 9. Now, we got to recall our Algebra 2 skills. Remember those factoring skills you guys worked hard on in Algebra 2? Uh-oh, we better remember those skills because that's what we're going to use. If I plug 3 in here directly, do I get an answer that's a real number? Or do I have an issue of I've got numbers I can't work with? I get a 0 in the denominator, right?
Yeah.
Okay. So now we're down to, could I factor the numerator?
Yes.
What does it look like if I factor the numerator? Now I've been writing this wrong up there. I need to change that. I really should have been writing this same limit all over again. I did not do that. But yeah, I need to be writing that. I'm sorry, guys. But numerator, what's the factor to become?
X minus 30 and then x.
Do we agree? What about the denominator? And do we agree?
Yeah.
So from algebra, what do we say is going to happen if I have an x minus 3 and divided by an x minus 3? What does that value actually represent?
1.
That's a 1. So now I should have this thing that says it's a limit that's equivalent to x approaches 3 of x minus 3 over x plus 3. And if I directly plug in the x being 3 now, do I get a number that's not real? Now I actually end up getting 3 minus 3 over 3 plus 3, which is 0 divided by 6, but we know that to really be 0. Again, 0 is okay as a limit, but if we plug it in directly and it doesn't work, our second stage, our second thought process needs to be, oh, you know what? We need to see if we can factor. So number 2 is try to factor and rename ones because x minus 3 over x minus 3 is a 1. It's renaming a 1 to that process. Okay? Would you like to see another one that does this type of example number 2, or is the one above sufficient to help you out with that? Good with that? Anybody else? Do we need to see any other example of this concept? We have other concepts we're going to look into, by the way. You were hoping this was it, I can tell.
Yeah, but then when you're on the phone line,
Yeah, you don't want that.